Linux works last week. So go over how the computers talk to each other now that we have a basic idea of how they work internally. Oh, we're gonna slide backwards. All right. So the rules of the talk, same as last time. Feel free to shout out questions, unmute yourself. I can't see any like emojis or anything like that. So feel free to interrupt. First time giving the talk, ask if stuff are unclear. If you know what you're talking about and you think I missed something or poorly explained something, feel free to interrupt me. Always rather have everyone learn rather than save some face. All right. So to understand the network, you're going to want to break it down into these 7 layers. We have the application layer down to the physical layer. As you might imagine, the application could be Firefox, and then down to the physical layer, that's the Ethernet or the wireless radio signal. And then we have everything in between. I don't have great examples from all of these because rather than using the OSI model in practice, we actually use the TCP IP model. But it's really good to like look at this and kind of get an idea that we're going to take the large amounts of data, the stuff that actually applications read, break it down into sessions, and you break it down even more so that each part of the layer only handles certain jobs. So here's the TCP IP layer right here. We have our application. This is Firefox, Thunderbird, most of the things that people actually think of when they hear of the internet. You have the transport layer, which is basically in charge of making sure this is TCP or UDP. TCP is in charge of making sure nothing gets lost in transmission. If a packet or piece of data gets lost as you're sending it over the wire, this layer right here is in charge of double checking that and asking for that information again. Then we have the network internet layer right here. These are your IP addresses. TCP or UDP uses this to figure out where to send the data. And you have the host network physical layer right here. This can be everything from your Ethernet to wireless. This is the actual physical. How do we get these electrical impulses from point A to point B? And then the above ones change that into data all the way up to your application. So we have the hardware MAC address. This is the lowest level one. This is how the most local network sees everything. This is below the internet label. Internet, so this would be below the IP label. It is 48 bits or this many addresses. You only will be used on your local address. So if you have a switch, this is only seen by that switch. If you have it, so this is what you're seeing by the actual hardware. MAC address is what you commonly see these called, or media access control. Nothing to do with your good old Apple computers. Let's see. They have assigned this stuff. You can normally tell who the vendor is of your piece of hardware by the vendor ID, which is the first, what is that, 6 octets. And then they'll put out a unique one for the last 6 octets. All right. Now that we have a way to communicate from switch to switch, how are we going to communicate from router to router? This is the big thing that I've worked with and that you're probably going to see is IP addresses or internet protocol addresses. These are unique in your network. And then there are some globally unique ones that allow you to send stuff across many different networks. We'll touch into the routing a little bit more later. They're divided into the client and the network addresses. Also in that a little bit more later, but you can see if this is, we have 8 bits worth of network, those would be the first, not 8 bits, 8 bytes. The first 2 chunks here could be the network, and then the last 2 would be client. This is represented with number dot number dot number dot number. And then because they thought that only 5 people would ever use the internet when they first came up with this, they only created 4 billion IP addresses and allocated them pretty poorly. Surprisingly, more than 5 people use the internet. So they had to come up with a new system. This is IPv6. The previous one was IPv4. What happened to the other 5, I don't really know. Now, rather than having a 32-bit number as your IP address, this is a 64-bit number represented as this with colons in between. I'm not 100% sure how to pronounce that. You're most likely still to be seeing mostly IPv4. The IPv6 is slowly becoming more common and has been slowly becoming more common for 20 years now. Any questions so far? See if I can see a chat or anything if people want to throw stuff there. All right. How do we get IPv6 addresses from the university? You're sad because I don't think you can get IPv6 addresses from the university. I've tried to figure out how to get IP.
Yeah, she does not allow IPv6 yet, at least for internal IPs. They have acceptance on their switches for routing to the external internet, but nothing internally. And that's mostly because of the network ISU's on, and that's the state of Iowa's, I forget the name of it, but it's the state of Iowa's special internet for government and educational facilities.
Yeah, so there was something way back up in here, the Slack channel. I was looking at doing stuff with IPv6 before, and this only really works if you have a publicly accessible IPv4 address. It lets you get IPv6 onto it. I do not have a 4 either, so I was also sad about that. And if you're in the university, you don't have an IPv4, I don't believe, unless you're working on research projects. But that is a useful service for getting IPv6 to stuff if you have an IPv4.
Or you can use some server, that works too. But that requires you to have a IPv4.
Yeah. So if anyone figures out how to do this stuff out in IPv4, I would love to hear. So we'll move on to net masks. These are the basically how the networks are set up. How IPv4 works is you have the first however many bits dedicated to the network and the last however many bits dedicated to the client. For example, a /8 network can have all of these numbers. So this goes from 0 to 255 all the way down. So that's a lot of different hosts on it, all the way down to the top here, which is a /32, which means the first 32 bits are taken up by the network address. And you can do some subnetting and whatnot with this as well. So you can have numbers in between 32, 24, 16, 8. But those are the most common ones you're going to see.
24 is the most common.
24 is the most common?
Usually.
Yeah.
I don't think I've ever seen a 32.
I mean, a 32 would be only one host.
Yeah, I don't think I've ever seen a 32. I've seen a 16, but it's usually 16 and 24, depending on the size.
Mm-hmm. I imagine you could call the one IP address that your ISP gives you a /32. But
maybe. That's typically not the amount, though.
Yeah. Some special stuff. The 10 dot addresses are 10. Let's see. There's the 10 dot, the 192, and the 168. 192.168 are some of the private ones. For example, here we have Iowa State's internal network, 10.0.0.1 all the way to 10 255, 255.254 is all of the internal addresses. You can see that this is a /8 because the first 8 bits, the first 8 bits are all the same. There's kind of a lot of hosts. Iowa State does not use, or for internal, they might have that many hosts. They don't have that many on their public. And then you can see down here some of the Iowa State's public addresses.
Internally, they use about 3/4 of their hosts currently.
Yeah. So then we have our public versus IP addresses. I touched on this briefly before. I guess I missed the 172 address range here. So these are the quote unquote private IP ranges. So basically, if you're going to set up a private network, which is some more complicated stuff, basically you'll have one router or firewall that connects the public internet, and then it will take all the requests and route them to specific hosts inside your private network. And then this lets you have a massive number of private hosts that aren't accessible from the public internet, but that can get to the public internet. Or if you don't have a router connected to the public internet, they can't get to the public internet. So here's a kind of a quick glance of routing. You can have these. Are you guys able to see my mouse?
Yes.
Yeah. All right. So you're able to have these areas. So this is a network. Then we can have this network right here, and then this network right here. We can have PC1 talk to server 1 without going outside of its network. So that just all stays right here in the switch. But if PC1 needs to talk with PC2, they'll go through the switch to the router. The router will say, we go over here to router 2, and then it will route down to PC2. So that allows both sides to get to each other, being on the different networks. This lets you do some fun stuff with like IP addresses. Theoretically, you could have, so this address, this switch right here, this IP address is 172.18, but you could have an internal IP range in here, which corresponds to say 192.168. So this one could be 192.168.0.1, and this one could have the same IP address as that, but since they're on separate networks, there's no conflict because this router, router 2, knows to direct traffic on, say, port 21 to PC2 based on its IP address. I'm sure that was clear as mud. Again, hop in if you have any questions, but I'll keep trucking on if not. Each computer and router have their own routing tables here. So let's see, we have PC0. PC0 will know that if it has an address in range 172.18-16, it goes to router 0. Or in .20, it goes to router 0, and then router. But if it has one in 172.16, it stays on this network, so you'd be able to go straight to your server without going through the router. But like I mentioned before, we'll mix it up a little bit. We'll have PC0 wanting to talk with server 1. Server 1's IP address to the public at this level right here would be the 172.118 with some port number, say port 80 for a web server. PC0 will ask for 172.18.0.0. I'll go, I need to go to router 0. Router 0 will go here. It'll look at its table and go, well, 172.118 goes to router 1. Router 1 will get it, and then it could say port 80 goes to server 1. So that's how that would work. And then you have a connection that they can talk between. All right. And then mentioned this kind of before, the NAT. Didn't mention it by name, but that was the ability of this router to be able to, say, send port 80 to server 1, but say send port 21 to PC 1. And that basically has one IP address to the NAT router, or the NAT network address translation router, and then that will take different port numbers and forward them to their internal computers. A couple common protocols that you're probably going to see. On the network layer, this is IPv4, IPv6, what we talked about before. And then we also have the ICMP. This is basically the troubleshooting and status update system. Then on the transport layer, we're going to have TCP and UDP. TCP is the method or the protocol that ensures all of the data gets through, nothing gets dropped, and if it does, it gets resent. UDP is the protocol that doesn't do that. So it just starts spraying packets, and if some of them get lost, some of them get lost. That's not anyone's problem, really, and it just don't get through. And then on the application layer, that's where we get some of the fun stuff. So everyone knows HTTP here. And the way most people probably know HTTP is typing in a URL, www.google.com. However, computers don't know what the W's and the dots and whatnot really mean. They understand the IP addresses. So what we did is we created DNS, or a domain name services. So your computer will ask whoever its DNS server is, hey, what's the IP address for www.google.com? It will either answer or it will pass you on to another one. This is recursive. Eventually, you'll get to the answer, and then this will give you an IP address, and then you'll ask that IP address for the website. We have FTP. This is just a file transfer system. SSH. If anyone's familiar with the terminal in Linux, this lets you basically get a terminal on the a remote IP address if the correct applications are running. SMTP. This is email. IRC is Internet Relay Chat, basically a chat method. Any more questions? Looks like we had a question if the lectures build on each other. No, this is the last number one that I see so far. I think we're going to go into some CDC stuff in the future, seeing as that's coming up, and then do debriefs on that. Have a little bit more of an awkward silence. Doesn't sound like anyone has more questions. Oh, go ahead.
For those of you that, does somebody have a question?
I think I just heard you.
Was it just me? Okay. Well, for those of you that have or may not entirely understand what's going on, feel free to post questions in Slack, after this as well. Yeah, that's really all I had to say.
Yeah. Feel free to DM me too if you feel embarrassed or something about asking questions in Slack. I enjoy helping people figure this stuff out. I'm a little bit swamped like tonight and tomorrow, but I'm sure I'll do my best to get to you as fast as I can. And I'd love to actually get to know and chat with some people. This is something that I'm not a fan of for the online stuff. I always enjoyed staying after the meetings and before the meetings and actually seeing everyone's face rather than their initials and chatting about class and security topics and complaining and stuff like that. So if all I can do is talk to people over Discord, I'll happily do that as well. So we'll go into a little bit of the networking basics for the Linux operating system. We have ifconfig, which is the tool that I'm used to. I think they're trying to phase this out with IP, but I don't know how to use that yet.
Yeah, they're phasing it out. Give it about 2 years.
Yeah. So I'll give you an overview with ifconfig. Although if you're going to try to learn it, maybe just take the general concepts from ifconfig and attempt to learn it in IP. That way you're not stuck learning something that goes end of life in 2 years.
And for all of these, your man pages are going to be very helpful as well. If you don't know how to access man pages from the Linux terminal, you can just like Google search man and then like the command name. So in this case, ifconfig, and there's online man pages where you can look at that have examples as well.
I would actually suggest Googling it, even if you have access to a terminal. It just looks nicer, in my opinion. But
I'll second that one. But you know, the Linux gods would hate me if I said that.
yeah, to each their own. If you want to feel extra elite and special, go ahead and use the terminal. All right. If up, if down, this will bring up a network interface. I think my computer has like half a dozen running now because of virtual boxes and whatnot. But for most people, this will be, you'll have one for your Ethernet connection, one for your wireless connection. If you have multiple Ethernet ports, you'll have a wireless interface for each one. If you have multiple Wi-Fi connections, you'll have multiple for each of those. This basically makes them start or stop. Route shows your IP routing table. Basically, this lets you go through, edit it, delete it, view it. Some troubleshooting stuff. I've honestly never had to mess with my routing table, but it is a useful resource to go back to if you're having really weird internet connection problems. FYI, all of these slides are on our Google Drive. So if you're ever sitting there wondering what these commands are, I would recommend coming back and just taking a look then. Netcat is a pretty useful tool. It basically just lets you send and receive stuff using UDP and TCP. So netcat-L 8080 just starts a listener on 8080. So anything that comes into that port, it'll just print out onto the terminal. And then you can have netcat, and then you can type in so the general one without flags, just NC, you can have a IP address or URL, and then throw in a port number. So we'll make a connection to that remote host at that port number. Real fun thing, if you want to transfer files, you can do it that way. If you pipe in like a cat of a file into a netcat that's sending, and then you write all the data that a netcat listener receives into a file. You can actually send files that way. You can also set up like different remote shells on there. This could be useful if you have a limited access to tools, like you can't install stuff. Set up a reverse shell. This is also good in like penetration testing and offensive side stuff like that. Or if you're trying to defend against that, preventing people from doing this might be very useful. -U has it communicate over UDP, which is the connectionist protocol mentioned from before. So dig, and its lookup and host are all ways to check the IP address, get the IP address for URL or the reverse. Ping and traceroute are very useful to see if your machine is even connected. If you want to check if you're connected to the internet, ping 8.8.8.8. If it comes back with timeout, you're not connected, you got to figure that out. Go ahead and throw traceroute in, and then traceroute will print out the route that your packets are going through. So it will, let's go back here to our model network. If we're on the PC 0 and we say traceroute to whatever is going to PC 1, it'll send back saying, hey, we first hit the router because I believe it ignores the switches. And then it'll say it'll say router 0, and then it'll say router 1, corresponding IP addresses for you, and then it'll say PC 1. So you'll get a list printing out something like 192.168.0.1, because that's probably the internal IP address for this router. And then you'll print out the .18 address for this router, and then you'll print out the address for this PC right here. Oh, and kind of the thought process is you can figure out where your network is kind of failing. If you have a failure between the two routers, this traceroute will tell you where it stops. So that's useful for debugging your network. Netstat just kind of gives you an idea of what is running on your network, right? Or what is running network-wise for your computer right now. So -an will show you like all of the connections that are currently to your server. RN will show you the routing table, so on and so forth here. Netstat is a good command if you're trying to figure out what's being connected or what's being sent from your computer. Figuring out exactly what you want to do, you'll probably end up Googling or reading the man pages, because I haven't memorized all of the commands yet, and I doubt I ever will. Telnet is the old way of managing servers remotely. This basically can let you get a shell on a remote server or send stuff to it. The reason why this is the way we used to do it is because nothing in Telnet is encrypted. So if I at work and I'm capturing all of the packets, and you connect to your remote server over Telnet, and you type in your amazing password hunter2, I will see that root hunter2 is the login information. And then I will be happy and you will be sad. This was replaced with SSH, which I believe is not in this slide deck. SSH is basically the secure way to connect to it remotely. There is more functionality hidden there, most of which I don't know about. But SSH is the way you're going to want to connect to stuff remotely. And then if you're really interested in all of this and in security in general, here's a couple of the classes. 230 is a really great undergrad one. Julie teaches that one. 530 for graduate level classes. That's with Doug. I'm not familiar off the top of my head with the 489 or the 541, but they're worth looking up.
I think those were only offered in the fall, I think now, but from what I've heard, they're pretty good courses as well. 530 is great, or 430 if you're undergrad. It's the same class.
Yeah, I mean, I'd recommend taking 530 rather than 430 because I think they're roughly the same amount of work. You just have to write a term paper for 530.
I would agree for that one.
And then you get to say that I took a graduate level class. So, little extra work for grad level class. Look good for resume and employment, and if you're getting into grad school, definitely helps. Any questions about this or security in general or life or anything?